Let's look at how Python syntax compares to Visual Logic syntax. Here's an example file. You can find this file on the course website. One of the things I want to point out is that notice that the first 10 lines of code that I've got in this file, first of all, they're colored orange. Why are they colored orange? Well, one of the neat things about using an integrated development environment or a Python-aware text editor is that it has the ability to provide syntax highlighting. These colors can help you identify more clearly certain parts of your code more quickly. It's just one other way to help reduce the strain on our brains as we write code so we can focus on the important stuff. So in this specific setup that I have, all of the comments for Python are going to be in orange. So what's a comment? Notice the first character on each one of these lines is a hashtag, or a pound sign, or whatever you want to call it. Because the first character on this line is a hashtag, everything after it will be ignored by the compiler. So anytime the compiler runs into, the interpreter, the Python runtime environment runs into a hashtag, it is going to go ahead and ignore anything after it until the end of the line. So what's really great about comments is that we can use them in our code to leave little notes to ourselves. I can also use them to leave notes to you. And what happens is anything that starts with a hashtag, any line that starts with a hashtag, is going to be a note to the human that's reading the code, and it will be ignored by the machine when it runs the code. So comments are going to be great, and it's going to give us an opportunity to annotate our code and kind of add some additional information as we walk through this sample file. Again, just as a reminder before I move on, that the line numbers that are presented here, those are only there because my IDE is putting them there. And in fact, for now, I think what I'll do is turn them off. When we want to output something to the screen in Python, we're going to use the print statement. The print statement is going to look different if you're using version 2 of Python versus if you're using version 3. The biggest difference that you're going to find is that the print statement in version 2 does not have any parentheses around it. So let's first take a look at the version 2 Python print statement, and then we'll look at how it translates in version 3. So you'll note that the line right here that I've just highlighted is a print statement. Notice that due to syntax highlighting, the print keyword is highlighted purple. Notice that between double quotes I have a string. We've already talked about the string data type in previous lectures. My goal here is to print this string to the console, and using my integrated development environment, the console is going to be this space down here at the bottom of the screen. So I'm going to run this program, and we're only going to focus on the first piece of output because you'll note I have a lot of other stuff in this file. And what you're going to note is this first line down here, hello world, is printed by this statement. One of the things, if you haven't already noticed, is that Python programs are going to run from top to bottom. So lines that are earlier in the file are going to run before lines that come later or further down in the file. So you'll note that this print statement prints out hello world. Notice that it has a space between the word print and the string, and notice there are no parentheses around it. Notice in Python we do not terminate lines with a semicolon. The line ending itself is enough to terminate the line of code, so it's an implied period, kind of like in poetry. You hit the end of the line, depending on the type of poem, I guess you could either pause or if you don't keep going in the same breath. I'm not a poet, but in this case, the end of the line is enough to signify that this is the end of a simple statement. What does this statement look like in Python 3? Well, notice that not only can we use comments to leave comments for ourselves in our code, we can also use comments to not run code. So if I put a comment in front of that line, and then go down to the next line down here, and get rid of the hashtag, you'll note now my Python style 3 style print statement is available. So notice that the difference here is that my Python 3 style print statement has parentheses around the string. There's some technical reasons why this is the case. The print function in Python 3 is different than the print statement in 2, but for now just note that if you're using version 3, you need the parentheses. If you're using version 2, you do not. And because I'm running on version 2, I'm going to stick with the version 2 of the print statements. Please note if you're running this file on version 3, as stated above in the comments, you'll need to actually go through and do this process of commenting the Python 3 print statements and commenting out the Python 2 print statements, or else you'll see errors. So you'll note that this print statement corresponds in Visual Logic with our output block. And so this is anytime in Visual Logic we would right click and we would put our output block into our program. Anywhere we want to print something or output something to the screen, we're going to write this line of code. So there's a direct correlation between this line of code and outputting items in Visual Logic. We'll talk more about different ways to format a print statement in a little bit once we get to creating variables and talking about assignment. The next item in my program is this line. This line is going to correspond directly to the assignment block that we've been dealing with in Visual Logic. In other words, I'm going to have a variable on the left-hand side of this assignment operator, and on the right hand of this assignment operator, I am going to have some type of arithmetic expression or some type of hard-coded value literal or some type of string value, and I'm going to take the answer of the expression or the item that I want to save into my variable. It will be passed from right to left and stored in a variable. And you'll note that I can then go ahead and print out that item. Again, using a Python 2 style print statement. The naming conventions for variables in Python are similar to those in Visual Logic, and it still has this right to left approach. So this should look very similar to the block that we've utilized before. And it should be pretty straightforward in terms of adapting this into your Python code. So let's see how this runs. And what you'll notice, this line of code here corresponds to the print statement here. So 2 times 2 is 4, plus 7 is 11. Again, why are there other things printing? Well, because I have more stuff in this file. So again, hello world printed because it's the first line of code in this file. Then the number 11 is printed. Why? Because this evaluates to the answer 11. I store 11 into the answer variable, and then I print the answer variable. So you can see how assignment works. You can see how one line of code in a file relates to another line of code as we add more items to the file. And hopefully you can see how comments are helpful in explaining things. And you can also see that comments are also kind of causing a lot of noise in this program. So there are cases where you can have too many comments. Great. So let's move on and look at how we can do fancier things with the print statement. Because if you note right down here under the number 11 are some things that look a lot more detailed. There are a couple different approaches to printing complex information to the console by combining different pieces of information. The first way we'll look at is using commas and passing those into the print statement. So you'll note on this line I have a standard Python 2 print statement. Notice that the first item in this answer, in this output, is the string the answer is, followed by a comma, and then followed by the name of the answer variable. And if I scroll back up here, you'll note this is the same variable that existed previously in my code. Since this was utilized earlier in my program, I have access to it down here. So I created this variable, stored a value in it, printed it, and then I'd like to reuse it again down here so that I have the ability to print this out as part of a sentence. So we're going to use this answer variable a little bit later too. So I'm going to hit run. And you'll note that here's all the code that we previously discussed, but here's the output statement for this specific question. In this case, what's happening is the print statement is concatenating these values under the hood or doing something else to kind of make this sentence come out formatted the way it is. Note I have no space after the S in is, but the comma operator here is actually putting a space into my sentence so it reads regularly. Again, the same process works in Python 3. You just have to add the parentheses around it. Again, there are ways to modify the behavior of whether or not a space gets printed, but I'm not going to discuss that here. One other thing you can do, though, is if you don't want to rely on the print statement to go ahead and format your strings for you, you can use string concatenation, which is the process of combining a string literal with values from a variable so that they can be output to the screen in a format that is appropriate to you. And so what you'll note is down here under answer is 11, I also have this other sentence, new string, period, answer is 11. So again, I'm going to be reusing that answer variable. So let's look at the line that's doing this. I'm going to be combining the process of assignment along with the process of concatenation. So let's look at the right-hand side of this operation first. I have a string literal that prints out the words new string, or that contains the characters that spell out new string. Answer is : space. And one of the things you're going to note is that in addition to adding two numbers, 2 plus 2 to get 4, is that the plus operator in Python is also the concatenation operator. In other words, it allows you to glue two things together to make a new whole, specifically in this case two strings. So if the context of the plus sign is two numbers, in other words, if it's between two numbers, it will add them. If the plus sign is between two strings, it will glue them together, concatenate them. So you'll note here's my string literal, my concatenation operator. And remember that in Visual Logic, the concatenation operator was the ampersand. In Visual Logic, that was what we used to glue strings together, but we're going to use the plus sign in Python. On the right-hand side, I have my answer variable. We've seen this before. A unique thing around that today, though, is a new intrinsic function that's provided by Python called str, or in this specific case, string. And what this does is that it takes the value that's contained in this variable and basically converts it to a string so that it can be glued to this other string. You can't really add a number to a word that doesn't make sense. If somebody said, well, what's 2 plus car? And you'd be like, what? That doesn't make sense, right? Because you're trying to take a word and add it to a number. But if you take two words, you can glue them together. So what this does is this makes sure that the value stored in answer, which at this point is the number 11, right? There's the value, the quantity of 11, but we want to treat that like the symbol for 11, the thing that we write to represent the quantity of 11. And string's going to go ahead and do that. And what this will do is glue that string value onto this other string literal. Once this operation on the right is complete, the new string will be saved into this variable called myNewString, and then I print it out here. I could have done this all in one step. I'm performing it in multiple steps just so it's a little bit easier to see what's happening. And ultimately, we get this value down here. If I wanted to add another thing to the end of the string, maybe you're bothered by the fact that there's no punctuation, so maybe we could put a bunch of exclamation points at the end. I can add another concatenation operator, another string literal, and if I end this and rerun it, you'll note that now it says new string answer is 11. So we can utilize the concatenation operator as well. So it's really up to you. Sometimes if you just want to print simple output, using a comma delimited list to the print statement is enough. But if you want to get a little more tricky and put a lot more things together, you may choose to concatenate values together and then print them out. You also may choose to concatenate strings together for other operations that don't even involve output. So concatenation is an important operation to know about, regardless of the way you plan to use it. Finally, if we know how to perform assignment and we know how to output, let's talk about how we can get values from the user. In other words, process input. So in Visual Logic, we had this block, and essentially what it did was it allowed us to enter a custom message that would be printed to the user and pop up a little window in the GUI environment, or put up a blinking cursor in our text environment if we were using the console. So we can perform this same task here in Python. So the line of code that's going to do this is right here. We're going to use the input intrinsic function. So it's going to be very similar in terms of naming to what was used in Visual Logic. Notice I do have parentheses here. In this specific context, they're required. And then I'm going to put a string literal inside of those parentheses, and this is what's going to be printed to the user to prompt them to enter output. What will happen is when this is run, your program will pause, a cursor will start blinking, wait for the user to enter a value, and the value that they enter will get stored into the variable on the left. So again, right to left operations. So let's run this. Here's all of the output from my previous code that's higher up in the program. But note that now I've got a space to enter a value. So I'm going to enter First, my name. Notice, just like in Visual Logic, we want to make sure that we put double quotes around our strings when entering them in. And if I hit enter, what you're going to notice, it told me twice that I entered Jason. And the reason it did that is because I want to look at it up here. You'll note I have two different approaches to printing this, one using concatenation and one using comma-separated lists to the print statement. Let's stop this real quick, though, and create an error. What if I forget to put the parentheses in there and just type Jason? Notice I get an error. And notice that you'll find that errors get printed directly out into the console output area as well. And then it's really going to be up to you to figure out why these occurred. Notice this says Jason is not defined. Remember that the double quotes are what make this a word and not a variable name. So let's go up here and look at how this worked. I entered the name Jason. Jason got stored in user input. And then when I went out and printed it, in the first case I used concatenation, the plus operator. I put user input inside of the str method. You say, well, you entered a word. Why would you need to put str in there? But let's rerun this and note that I don't just have to enter my name. I could enter a number like 17, and it still works. So by wrapping this line of code or this variable in the str function, it's a way for me to guarantee that this will still operate even if the user entered something else. So when we're using concatenation, we really want to make sure we use that string function, str function. But in the case where I'm just using common delimited lists, I don't need the str function. Notice it worked fine with whatever data type I pass it. So two different ways to achieve the same thing. Let's continue and look at the final example down here. Same thing, I have the input statement. In this case, I want to add a number or ask the user to enter a number, and then I would like to use that number in an operation. One of the things you'll note in this specific case is I know for a fact that I absolutely need a number. I don't care about getting a string or any other piece, so if the user doesn't enter a number, in this specific case, I want the program to crash. There are ways to make sure it doesn't crash, but at this point, that's what will happen. So notice I have wrapped this entire statement in the int function. Int is like string. If string guarantees that this thing is a string, then int will do its best to make sure that whatever is entered here gets converted to an integer, right? A whole number. So notice down here, if I want to enter this value, I'm going to go ahead and enter 17 again. And then it tells me the answer is 28. So the input statement printed this prompt. I entered the number 17. The int function just double checked that it was basically a number. If I had entered a string, and we'll do that in a second, I would get an error. The number 7 was passed into the user input variable. I then took the number 17 and I added it to the variable answer. Well, wait a second, where did answer come from? Scroll all the way back up to the top of our program. Remember the answer variable that we created earlier in the file, right? 2 plus 2 plus 7 was 11. It's still valid. It still exists. It's waiting around to be used. So in this specific case, I took 17. It was added to 11. The plus operator is used in the context of two numbers, and it produces the answer of 28, which gets stored into this new answer variable. And then finally, I use this print statement and the comma operator to print out the value. The final answer is 28. How would this work if I entered the wrong value? Well, I'm just going to quick enter J because this is my previous print statement. And I accidentally deleted that line of code, but we'll leave that there. So notice that this was my previous print statement, but now I want to go ahead and enter a number. What happens if I don't enter a number? What happens if I enter a string again? Notice that I get an error. And it says, invalid literal for int. And essentially, it cannot make that value j into an integer. Interestingly enough, what happens if I type 17 in double quotes? Notice it worked there. What happens if I use it here? Notice that it worked. Here's the thing. The integer function, if the thing looks like a number, it'll try its best to convert it to a number. So it actually took the string 17 and converted it to the number 17. So it's really up to you how you want to use these items. And these are great topics for discussion on the class discussion board. My goal here is to keep this simple and demonstrate how these things tie directly to the visual logic blocks. And we will continue to explore in more depth how these things work as we move forward.